Our lab was over dilutions and spectrophotography. To start our lab, we first made our 3 dilutions. We transferred them into our 3 cuvettes until the meniscus reached the mark and did the same for the unknown. We then moved to the spectrophotometer room and opened the scan application. We set the parameters from 800 nanometers to 200 nanometers. Then we opened the lid to our instrument, picked up our blank cuvette, which is DI water for this lab, and wiped it with a Kim wipe. Then we placed it in our spectrophotometer with the wiped sides facing the light beam. Then we closed the lid and zeroed the spectrophotometer in the scan program. We used a blank solution to zero it to make sure that the spectrophotometer only measures the light absorbed by the component of interest and not the light from the solvent. Then we took out our blank and repeated the process with our stock solution. We wiped our stock, placed it in the spectrophotometer, and closed the lid. Then we pressed the start button, named our file, and generated a graph. We used the track feature on the software to find our lambda max, also known as the maximum absorbency wavelength. As you can see here, we found our concentration for our stock, which was 609.93 nanometers. We then recorded this value into our notebook. We then took out our stock, closed the lid, and switched to the Simple Read software. After opening the software, we went to Setup and imputed our lambda max value, 609.93, into the parameter. Then we got our cuvette with DI water, wiped it, and used it to zero the instrument.
Once the spectrophotometer has been zeroed, remove the cuvette with the DI water, pick up the cuvette with the stock solution, wipe it down with a Kim wipe, and place it into the spectrophotometer. Once the lid of the spectrophotometer is shut, press Read on the Simple Reads program to record your first absorbency value. Once you record your first absorbency value, be sure to write this down in your lab notebook. After you have written down the first absorbency value into your lab notebook, remove the cuvette of the stock solution, then repeat this process with your first dilution, and then repeat this process with the second dilution until you have recorded the absorbencies for all your cuvettes. Though it is not shown in this video, this group did clean their work area. Please remember to always clean your work area to ensure a safe environment for your group as well as all the other people that are participating in the laboratory.
The equation shown is the standard deviation of a population, which was used to find the standard deviation of the measured absorbency values. The standard deviation or absorbency value was then used as a slope in the equation y equals mx plus b to find the y-intercept b, or in this case, the concentration at the standard deviation absorbency value. Then we went to create the following graph and noted the relationship between absorbency and concentration, noting that when the absorbency is low, the concentration of the solution is also low. When the concentration of the solution is high, then the absorbency value will be high. Time for some bloopers! Mostly like them though.
Oh,
Well, you should do it like a V, like do it like this, but I'm like dancing. The difference is you're focusing on just one movement.
Go. On your, you can come down the street.